Hello and welcome. Today we'll be looking at the integral of sine cubed and cos cubed. I'm going to show two ways of doing these particular integrals. The first one is by substitution, which is the standard way you'll normally be taught to do this, but there's another one which is by clever manipulations and reverse chain rule. So let's start with the sine cubed. Okay, and the substitution method requires a substitution that perhaps we'll never have thought of unless we've seen it before. The required substitution is in fact u is equal to the cos of x. If you have sine cubed, sine to the fifth, which I might do a video at a later stage, sine to the seventh, require cos of x as the substitution. Let's differentiate it and let's see what happens. Du by dx, of course, minus the sine of x. Make dx the subject, so dx goes to this side, is du over negative sine x. Okay, let's go back to our integral and see how it will transform. Well, of course, we cannot change the sine cubed. Let's leave him. There's the sine cubed. And we can replace the dx at this stage. So that will be du over negative sine x. Okay, that will definitely, we can cancel one of the signs. So let's do that. And let's keep in mind, let's have a minus. The minus I'm going to write in front. And sine cubed over sine x is, of course, a sine squared of x. But careful, this is du. We still need to change everything into u's. Well, the way back into u's is through causes. And at the moment, we got a sine squared, which is not too bad because now we can use a standard identity from year 12. So that's minus bracket 1 minus cos squared of x. Still du. Bit of a tidy. Negative 1 plus cos squared of x. Still du. But now the cos of x is actually now u. So we can actually swap this into a negative 1 plus u squared du. And that's a very straightforward integral, which we can do on the next line, which of course it will be negative u, because the integration with respect to u, plus 1/3 u cubed plus a constant. And let's not forget to put our substitution back in, which is of course the cos of x. So that's going to be minus cos of x plus 1/3 cos cubed of x plus a constant. So that's the standard way of doing the sine cubed of x. And let's look at the corresponding integral, but with a cos cubed. So let's make some room. It works in analogy. So for the sine cubed of x, the substitution that we used was u is equal to cos x. Now if we have cos cubed, we're going to use the substitution u is equal to sine x. It works in analogous way. So let's do that one very quickly. This is now the cos cubed of x dx. By substitution, we use the substitution now, u is equal to the sine of x. Same thing, du by dx is now positive cos of x, and my dx will be, of course, du over cos x. We'll return to our integral. We're going to leave the cos cubed as it is. There's nothing to do, of course. And the dx, we're going to replace it with all of this. So that's du over cos of x. Cancel one of the causes, as we did earlier on. So that will give us now a cos squared of x, but integrated with respect to u. Use the standard identity from year 12. So we're going to write this now in terms of sines. The intention now, when we swap into sines, now that we've seen how this works, is to go back into sines and then back into u's. So it's going to be 1 minus sine squared of x du. And of course, this will now take us back to 1 minus u squared, because of course sine x is u du, and the integration is now trivial. 1 integrated with respect to u is u, minus 1/3 u cubed plus a constant, which of course will give us now the sine of x, going back into our substitutions, minus 1/3 sine cubed of x plus a constant. Okay, a little bit of enrichment now. So we're going to do exactly the same things, but let's do the sine or so we'll do the cos. It doesn't really matter. I'll do the sine. How do we do it without the substitution? Okay, this is now the non-substitution method, which is basically recognizing differentiations and manipulating. So let me make an attempt to integrate sine cubed x with respect to x. And the first thing I will do is I will split this into a sine x multiplying a sine squared of x dx. The next thing that I'm going to do is I'm going to replace this with correspondingly as I did in the previous example, with 1 minus cos squared. So this will become, on the next line, sine x minus cos squared of x. My intention is, of course, to multiply it out. So we got sine x minus sine x cos squared x dx. And of course now this is integrable. This of course integrates instantly. The sine of x comes from a differentiation of a cos of x, but the cos differentiates to a minus, and therefore we need a minus to take care of. So that's this bit here. The question now is, what is this? Is it something we should be able to see? And the answer is, with practice, we should be able to recognize the chain rule that took place in there. If we differentiate a cos cubed, I'm just doing it down here so we can actually see what's going on. If we differentiate, we will get 3 cos squared of x, so the power goes down by 1, and then times the derivative of a cos, which is a minus sine. So if we look at what we got when we differentiated cos cubed, is negative 3 cos squared x sine x. If we look at what we got in there, we got everything except that 3. We're the minus even, so we got the sine of x, of course, the cos squared, we're just missing that 3, and therefore this requires to differentiate the cos cubed with a third in front of it, and that will, of course, have finished the problem. Okay, and I'm not going to do the sine cubed in the same way, but it works in analogy. I hope you followed that and you enjoyed it. For the time being, this is the end, and I'm going to sign out. See you soon.